What keeps the sun spinning? Have you ever wondered about this fascinating celestial phenomenon? Let's explore the captivating science behind the sun's perpetual motion. Nothing keeps the sun spinning. In fact, it spins under its own inertia, following a fundamental principle known as the law of inertia, as discovered by the great physicist Sir Isaac Newton. The law of inertia states that objects in motion tend to stay in motion unless acted upon by an external force. This means that if an object is already moving and no force acts on it to stop it, it will continue moving under its own inertia. Let's consider the example of a hockey puck sliding across a frictionless surface. Without any obstructions, it would continue to slide indefinitely due to its own inertia. The law of inertia can be generalized to the law of conservation of momentum, which applies to both linear and rotational motion. According to this law, the total momentum of an object remains constant when no external forces act upon it. When it comes to rotational motion, this law is known as the law of conservation of angular momentum. It states that the total angular momentum of an object remains constant if it is isolated from external influences. Imagine spinning a child's top. Once it's set in motion, it continues spinning for a while. This is because of the conservation of angular momentum. In the absence of friction or external interference, an object in rotational motion will persist in its spinning. In space, where friction is negligible and there are no external forces to hinder its motion, the sun keeps spinning due to its own angular momentum. This phenomenon is not unique to the sun. All planets, moons, and stars spin for the same reason. Now, let's delve into the origins of the sun's spinning motion. The sun and our entire solar system emerged from a colossal cloud of gas and dust. Random gravitational interactions within this cloud imparted a minute amount of rotational motion to it. Almost every cloud of fluid material in the universe possesses some level of rotational motion due to statistical probabilities. As gravity pulled the gas and dust inward, the cloud collapsed, giving birth to the sun and its surrounding planets. During this collapse, the conservation of angular momentum played a crucial role. Just like a figure skater extends or retracts their arms to control their rotational speed, the sun compacts as it forms, causing its speed of rotation to increase. This process is governed by the law of conservation of angular momentum, which states that the product of an object's moment of inertia and its angular speed remains constant if no external forces act upon it. You can even experience this effect yourself. Find a swivel chair, lift your feet off the ground, and start spinning. As you extend or retract your arms and legs, notice how it affects your rotation speed. This simple demonstration helps illustrate the concept of conservation of angular momentum. Another example of conservation of angular momentum can be observed when water spirals down a drain. As the water compacts into a smaller distribution, it accelerates its rotation to maintain its angular momentum. Contrary to popular belief, the swirling motion of water down a drain is not caused by the Coriolis force, but by this conservation principle. In synopsis, the sun keeps spinning due to the absence of forces stopping it. Its initial spin was inherited from the rotational motion of the gas cloud from which it formed, driven by the conservation of angular momentum. As a result, the planets in our solar system also follow this motion, orbiting the sun in the same direction. The sun, a magnificent celestial body, keeps performing its exquisite movement in the universe, capturing our attention and kindling our desire to learn more. Its rotation serves as a reminder of the exquisite natural principles that control our universe. As we contemplate the mysteries of the universe, the sun stands as a shining testament to the elegant principles of motion and the vast wonders that await our exploration.